Good morning. Today we'll be studying the pressure and kinetic energy, which is one of the equilibrium properties in KTG. So, in the kinetic theory of gases, the pressure is assumed to be equal to the force per unit area exerted by the atoms hitting and rebounding from the gas's container surface. That is the pressure applied by the gas on the container. So, first we need to focus on the notation that we'll be using in this derivation. N is the number of molecules of gas, and we need to consider a pretty big number. We are considering that the container is having a lot of molecules inside it. Then M is the mass of a single molecule of gas. V, this is the volume of the cube or container. This is equal to L cube. P, this is the momentum of a molecule. Delta T, this is the time interval within which the particle impacts one specific side of the wall once. So, if the particle is here, it would go and impact this and come back to this original position. So, the time taken for it to do this whole motion, this is delta T. Then we have L. L is the distance between opposite walls, this and this wall. The distance would be L. Then we have Vx mod, this is the average possible velocities of the in particles. Then we have K, this is the translational kinetic energy of the gas. So, this is all the notation that we will be needing. Then let us go ahead with the derivation. So, the gas molecule, we are assuming that we have a single molecule, like we are focusing on a single molecule. It is moving with the velocity Vx, it collides with this wall and comes back, and this collision is an elastic collision. So, the velocity with which it would be returning is the same, like Vx. So, the change in momentum would be equal to P final minus P initial, which is equal to Px minus of minus Px, which is equal to 2Px, and that is equal to 2 mVx. And the distance the atom will travel to reach its original position again would be equal to 2L. Hence, remember this time. So, this time would be equal to 2L by Vx. And the force applied by the particle on the wall would now be delta P upon delta T, which is 2 mVx square, and delta T was 2L upon Vx. So, this would be mVx square by L. And the total force on the wall due to collision by multiple molecules, like all of the molecules impacting with the wall with a range of possible values, is F is equal to N mVx square. Here we will be using the average notation upon L. Since the motion of the particles is random and there is no bias applied in any direction, the average squared speed, that is Vx square, this would be equal in each direction, that is Vy square would be equal to Vz square. And by Pythagorean theorem in 3D, the average square speed V square would be equal to Vx square plus Vy square plus Vz square, and therefore we will be having like V square would be equal to 3 Vx square, and this means that Vx square is equal to V square upon 3. So, let us put this back here, and we'll get F is equal to N mv square by 3L. So, this force is exerted uniformly on an area L, as we are still talking about the force on the on that particular wall. Therefore, the pressure of the gas is F upon L square. So, we were talking about this wall, right? So, this is the area of one side. We considered it to be a square container. so this area would be L square. That's why now we have N m v square upon 3 L cube, and this would be the volume now. And we already know that K is equal to N 1 by 2 mv square. So now we have PV is equal to 2 by 3 K, and we got this from this equation and this equation. So this is an important result of the kinetic theory because it relates pressure, a macroscopic property, to the translational kinetic energy of the molecule, which is a microscopic property.